Okay, so today for you guys in Calc 3, we only have, if you look on the far right side of the board, only 5 pages of notes, which is really only 4 pages of notes because the last page is just your homework assignment, okay? I will tell you the problems can get long and not necessarily intensive, just some work to be shown as you try and solve these things. Luckily, you have a little bit of experience with this because you've done velocity and acceleration word problems or free-falling problems back in Calc 1. If you remember that free-falling type of problem that we even did yesterday with the cat. So yesterday with the cat, cat free fall, the equation we had was h of t is negative 16t squared plus v naught t plus h naught. Okay. Now, for vectored value functions, I want to split this up a little bit and give you everything in terms of x and everything in terms of y. So when we think about these things, you realize Calc 1, this whole problem in Calc 1 is really 1D. It's really about the height, up and down, with respect to time. Well, in Calc 3, for the moment, I want us to do in 2D, so Calc 3, it's a 2D type of thing. I care about the height, which is the y component, and the distance, I should say horizontal distance, which is the x component. Okay? So, the part that matters then is really buried inside the v naught. Okay? We're going to start breaking this v naught into this. If I throw the cat, so instead of dropping it, kind of a throw, you have to realize that there's a couple components to this throw. If I give you a certain angle, okay, there is, and let's say this is my initial velocity, okay, then v naught cosine theta would be represented by this part, and that's the x component. And this part here would be v naught sine theta, and this could represent the y component. So based off a certain angle, there is part of that velocity is being used to throw it horizontally, and part of that velocity is being used to throw it up. And I want to start to separate those two components so you can really extract out what's going on with the x and what's going on with the y based off time. Okay? Now, if you look back again at the original equation, this guy and this guy are all based off y, along with this guy. Those are all y components. And then the only x component is buried into there. Okay? So, when I pull this all together for vector valued functions, vector valued functions, you can say this, r of t equals, so the x component is only that blue highlighted part, so you'd say v naught cosine of theta times t. So that amount of the initial velocity, the cosine amount, is how powerful you are throwing it left and right. Okay? So only the cosine part talks to you about how fast you're throwing it or how much oomph you're throwing it left and right. Anything vertical has no effect on the horizontal. And likewise, anything horizontal has no effect on the vertical. So then for the vertical part, you still have the negative 16t squared, because that's all about gravity, and gravity is all about up, down. Gravity has nothing to do with left, right. You have that. You have the initial velocity in terms of sine. Okay, that's the initial velocity part, all about the y component. And then you still have to take in care the h naught, which is the initial height. Okay, so that's how you extract out the x and the y components of basically a free-falling object or a projectiles, assuming no air resistance. It's interesting, we might have talked about this yesterday, but my Calc kids struggled for a while, my Calc 1 kids struggled for a while with, if I throw, let's say, a baseball, they didn't think that's a free-falling story problem because they said you threw it, so it's not free-falling. Well, there is a difference between just dropping a ball and throwing a ball. When you drop a ball, what's that initial velocity? 0. But when you throw a ball, you do have an initial velocity. And so right up here, they didn't believe me that you did have an initial velocity, but that's okay, because right when I threw it, I'm not continually throwing it. I throw it, so right at that moment, I get an initial velocity, but that's it. Then it's free falling. Now, it's different than a rocket ship that right when I light it, it starts blowing up, and it continues to have those fumes and gases that continue to blow it up. That's not free falling. But it's okay to have an initial velocity, an initial throw, or initial hit, or initial jump. That still can be free falling because right after that initial, you have no more forces acting upon you except gravity. So today, instead of doing the cat free fall from yesterday in terms of just height up and down, we are now going to explore with vectored value functions in terms of x and y. So we're going to explore both the x and y. And we're going to start, and we only have 3 of these problems, we're going to start with baseball, because I love baseball. So take a moment to write this down, and then we will kind of extract out how to separate the x and the y and solve. Okay, so let's see. A baseball is hit at 3 feet above the ground. So that is definitely an h naught. At 100 feet per second. Okay, so now this part here, at an angle of 45 degrees with respect to the ground. All of that is your V naught. Now remember, you want to extract out the x and y components of that. So it's build a triangle and see how much of that 100 feet per second is on the x and how much of that is on the y. So visually, if you want to see it, this is 100. Here's 45 degrees. So this is 100 cosine of 45, and this is 100 sine of 45, okay? Which happens to be, in this, 50 square roots of 2, and, of course, 50 square roots of 2. So that 100 feet per second is equally split on helping the ball go out and helping the ball go up. Now, when I say equally split, that does not mean you just divide it in 2 and say 50 goes out and 50 goes up. Because it's on that right triangle, but it is split equally on how much of that power or how much of that speed is going towards the right and going towards the up. Okay. Now, there are actually 2 questions in this one. The first one says, find the maximum height reached by the baseball. And the second one is, will it clear a 10-foot high fence located 300 feet from home plate? Okay, so there's 2 questions buried in this. But before we start those questions, let's already extract out our vectored value function. Okay, so it would be 100 cosine 45t, and then negative 16t squared bit, plus 100 sine 45t, plus that initial height of 3 feet. Okay? And we already said with that, we already simplified it, that r of t is 50 square root of 2t, negative 16t squared plus 50 square root of 2t plus 3. Okay? And that first question says, find the maximum height reached by the baseball. Okay, so max height of baseball. This is kind of right back to that Calc 1 stuff. Max height is when not r of t, or not r prime of t is 0, but just the y component equals 0. Again, if you just look at the up and down part, it's when the derivative of the y is 0. Because when the derivative is positive, it's going up. And when it's negative, it's starting to fall back down. So it's right when it hits 0 is that turnaround point. Okay? So we can just from here say, okay, I already know who the y of t is right here. So I can say y prime of t is negative 32t plus 50 square roots of 2. And this is completely Calc 1 right now. I want to set this equal to 0. So I got 32t equals 50 square root of 2. T equals 50 square root of 2 over 32, which is about 2.2 seconds. Okay? And this again is the time to max height. What you're going to realize on all these questions is they're basically Calc 1 questions. And I'm extracting out an x equation and a y equation. And why it's a Calc 1 question is I focus only on the y for a moment, or I focus only on the x for a moment. And I might cross them back and forth and use a time from the y to plug into the x or something like that. But the Calc 3 part is really just extracting out into the x component and the y component. Okay? So that covered the very first question about finding the max height. It was at 2.2 seconds. Now, did it say, it said find the max height. So now I can find the max height by plugging in that 2.2. And I'm going to plug in that 2.2 right into the y. So y of 2.2 would be, and I did this already on my calculator, 81 feet. Okay? Notice, so again, this whole question was all about y stuff. Okay? Now the next question is will it clear a 10-foot high fence located 300 feet from home plate? Okay, a couple ways to do this one. So the question here is it a home run? And the whole key to this is I need to be above 10 feet at 300 feet out. So basically, if you look at a point, if there's a point right there that is 300, 10, and I hit my ball starting at 3 feet high, so not off the ground, but at 3 feet high, and I hit it, the whole question is, does that shot right at 300 feet, is that above or below 10 feet? So the whole thing is, at 300 feet, how high am I? Okay? If I'm above 10, I hit it. If I'm below 10, I didn't hit it. Okay? Another way to do it is you could ask yourself, when you hit it, when I'm at 10 feet high, what is my x value? Now, if my x value is less than 300, I didn't hit a home run. If my x value is more than 300, I did hit a home run. So you can kind of solve this problem two ways. At 300 feet on the x, how high am I? Or you could say, when I'm 10 feet on the y, how far am I? Okay? When I do this problem, I tend to think of the red projectile with the green thought. 300 feet out, what's my height? Okay? So let's look at that. So 300 feet out is what I'm looking for. So 300 feet out is x of t. So I want to know, when is x of t equal to 300? Which is, when is 50 square roots of 2 times t equal to 300? And that is t equals 300 over 50 square roots of 2, which on my calculator was 4.24 seconds. Okay? So it took my ball 4.24 seconds to reach the fence. Now I just don't know how high off the ground it is at that fence. So to do that, you can go, did it clear the fence? Clear fence. So I'm going to plug in that time into my y. So y of 4.24, and when I plug that in, I got 15 feet. So yes, home run, because I'm above that 10-foot fence. Okay. So again, really Calc 1 questions today, which makes it kind of nice. I do want to show you a third question that could be a good one, and we won't do it. But a third good question would be, how far was the home run? I set up the two setups for you. You'd plug in, when is y of t 0? And once you find that, you can plug the t into the x for a distance. And now realize, when y of t is 0, this is a quadratic. You're going to get two answers, as you normally do with quadratics. I'll tell you, one answer is going to be a positive, one answer is going to be a negative. And if you're going, what? How's that work? Well, think through this. The initial time, I started up at 3, and I shot out, and there's your parabola. So you're going to get a hit out here at some positive time. And we already know it's above 4 seconds. So 1, 2, 3, 4, because what did we say? We figured out that at time t equals 4.24, it was something like 315. So it's going to be a little bit after 4 seconds you're going to hit the ground. The negative time is going to come from this part. You have to realize a parabola, it doesn't care about the time part. It's going to go back and forth. So there's going to be a time component here that doesn't make any sense. So you want to use the negative time, you use the positive time when you continue on with that question. Okay? So I'm going to stop this video, and then I have 2 more problems that we're going to solve on the next videos, and then you'll have your homework.